Question 19. The energy profile diagram for the formation of ammonia is shown. Ammonia is the product formed from half a mole of nitrogen gas and 1.5 moles of hydrogen gas in this reaction. The activation energy of the reaction can be thought of as the energy barrier for a successful reaction, which is going to be the height of the hump that the reactants must overcome in order to form the product. And the overall enthalpy change of the reaction is negative 46 kilojoules per mole, which is the difference in energy level from the reactants and the products, regardless of the pathway it takes. This question asks for the value of the activation energy for the decomposition of ammonia, which is going to be the reverse reaction as shown in the energy profile diagram. Let's draw a second energy profile diagram with ammonia now as the reactant. The energy level of ammonia is going to be the same in both energy profile diagrams. In this reaction, ammonia is decomposing into these substances. So the energy level of these substances again will stay the same in the new energy profile diagram, which is going to be above ammonia here. So I'll copy the reactants and the products over with exactly the same energy level as what the first energy profile diagram has given me. From the first energy profile diagram, it tells us that the energy level difference between these substances and this substance is 46 kilojoules per mole. So the energy level difference between the same two substances is going to be 46 kilojoules per mole. And if you write this in terms of overall enthalpy change for this reaction, it is going to be a positive enthalpy change of the same magnitude of 46 kilojoules per mole. At the peak of the hump in the first energy profile diagram, we can think of this as an activated complex or an unstable complex that is halfway through the reaction from these reactants to these products. So if we write out a rough sequence of events from the reactants as this pair of substances to the final product that we want, ammonia, at the 50% completion mark, there is this activated complex which has bonds that are halfway about to break from the reactants and bonds that are halfway formed to form the products. This activated complex is going to have the highest energy level, which is why it is located at the peak of this hump. If there is insufficient energy to overcome the activation energy barrier, the activated complex can reverse and form back the reactants. But if there is enough energy to overcome the activation energy barrier, the activated complex can successfully be converted to the product. So the same peak, which is going to be the same activated complex between the same two groups of reactant and products, is going to be located at the peak of this hump on the second energy profile diagram. The first energy profile diagram tells us that the energy level of this activated complex is 119 kilojoules per mole above this pair of substances. So if we translate that into this energy profile diagram, it is the same, 119 kilojoules above this same pair of substances. So the height of this portion of the hump is going to be 119 kilojoules per mole. Since the question asks for activation energy of this reaction, we must keep in mind that activation energy refers to the entire height of the hump that the reactants must overcome. So the entire height of this hump is going to be from the energy level of the reactant all the way to the peak of the hump, which is going to require us to add 119 and 46 kilojoules per mole. Therefore, the total activation energy 165 kilojoules per mole, leaving us with D as the correct answer.